Yes, hello friends, welcome to BISP Solutions, myself Ashwin, and today we are going to see BISP. First of all, let me tell you, BISP Solutions is a tech company and provide technological solutions. Now, today's video, in our today's boot camp, just give me a second. So now in our today's boot camp we are going to see multilayer perceptron and the deep neural network, right? So and today's the main thing that we are going to explore is that I'm giving you, suppose one scenario, take one scenario. As we know that how deep neural network takes the decision and how we predict the data. Suppose if I give you a list of all the YouTube videos, and along with that the data I have given you, right? The data I have given you, like how many videos are having what number of items. Just give me a second. I am let me open that also. Here, just a second. Just a second, let me open that also. Now see here, for example, I am having a data, or take a scenario, I am having a data. That data is collected from YouTube. Now that data Excel sheet contains, let me show you practical only. Look at this: view count, like count, comment count, definition, caption, subscribers. Now this is the data of several videos. Like, just take an example, 159 videos, and the videos are having what type of content, how many what we say, captions, subscribers, total views, total videos, right? These are the channels. The data is given from the channel, right? So published in which year, duration in seconds, tag count, title length, and the description length, right? So this data is given to you. YouTube video quality, it shows you the YouTube video quality. And what we are going to derive, that is, we will give the fresh video data, and then we will derive that exactly what type of what is the quality of that video, right? So now today we are going to see this multilayer perceptron. Now what is this multilayer perceptron? First of all, we will see what is deep neural network. A deep neural network is a type of artificial neural network with multiple hidden layers. Now let me connect you with a real life example. Multiple hidden layers means exactly what? See, the point when the input is given to you, and the point when one output you have to produce. For example, I have been given 10 candidates for the interview. Now out of that only one vacancy is open. So how would I select the candidates? Now imagine that all the 10 candidates, they know the answer very well, right? Now it is not possible that I should recommend all the 10 candidate names. So out of that, now I will create one by one step, one by one layer. I will check that how they speak, the way they speak, the tone, their tone, how they speak. Then I will check the attitude level, exactly how, whether they are polite while speaking, whether they are polite. Third, I will check what is the confidence level. So these are the different layers that in our daily life our brain works like this only, right? So that mechanism that we have created in this deep neural network. Deep neural network is also doing the same thing, right? But with the help of the algorithm. That's it. Now the input layer is given to the deep neural network, and based on that it has to produce the one output layer, right? Now see here, what is multilayer? A multilayer perceptron neural network belongs to the feed-forward neural network. It is an artificial neural network in which all the nodes are interconnected with nodes of different layers. Feed-forward, that means whatever the output of this layer is feeded to the next level, to the next layer, right? So that is called feed-forward. Now, in this neural network, when let me show you with an example. Look at this. Right, this is one layer and this is the another layer, and the combine of this is, that means only the green quality, the best quality is separated, right? So that is what it is doing. As I have explained you in our previous videos also, we have seen this multilayer perceptron. So this multilayer perceptron works on different layers of neural network. One layer works for separate data, another layer also works, but this output is forwarded to the next layer. Just like I have given you an example of the interview process. 10 candidates, they are able to answer, okay, no problem. Second layer, I will check the attitude, okay, out of which 8 are selected. Again in the next round, those 8 candidates will be forwarded to the next layer. Next layer, I will check the way whether they are polite or not, attitude, behavior, and then I will check the confidence level. Now out of which 4 are selected, then again these 4 are forwarded to the another layer of filtration. I will check the background, because we want a candidate that can run for a long time with the company, so I will check that in that point of view also, and finally one candidate is selected. So same thing is here. When the machine has to produce one output, right, in that case if the input is given, so on different criteria, different hidden layers are created by this multilayer perceptron, and one output of this layer is feed forwarded to the next layer of the output, next layer of this neuron, right? And then finally after so many hidden layers, it produces one output, just like this. Suppose if the target is to separate both of them, right, separate the orange dots and separate the green dots. So what it will do, it will first do vertically separation, then it will do the vertical separation, and out of which only whatever the what we say, the intersection or the common thing, that is extracted. So in this way it works. Look at this. This is the horizontal separation it has done, the vertical network, the vertical regression, and then ultimately whatever the combined is, that the intersection we can say. Look at this. So it totally works the same way as our brain works, right? So this algorithm works the same way. We just need to, if we are able to connect our daily life example with this, it would be far easy for us to understand this. First of all, now look at this. Now what are we going to cover? In this module we are going to cover a standard PyTorch workflow. First of all, we will see the workflow also, right, in the backend, how this workflow works, right? Let me show you this also. This is again as previous thing that we have already, but one more time we have to go through on this so that you will memorize this, right? Get the data. First of all, the data is collected, right? So get data ready, now that data is converted into the tensor. Tensor means it's a like a matrix. If you have seen the face recognition machine, just like biometric, in biometric we put our finger and it detects the fingerprints. Same thing is in face recognition machine also. You have to stand in front of that machine, it will take the snapshot of your image or your face, then that face image will be converted into the tensor, and the tensor will be matched with the tensor which is already available into the database. And if it is matched 90%, that means you are the same person that the machine is looking for, and then it will say okay. Same thing with the fingerprint machine also, same thing. Now here the data, the images are converted into the tensor. Now build or pick a pre-trained model. Now pre-trained model means same thing, loss optimizer loss function, the optimizer function, that means the loss between the prediction and the actual. Then build a training loop, that means epochs, that we were running epochs one by one. After that, here also in this example also we will run the epochs, right? It's a repetition for the training. Then after that, fit the model to the data and make a prediction. First of all, it will make a prediction exactly how much percent it is perfect. Then evaluate the model, eval function, I will show you that also. Then improve through experimentation, that means epochs running again and again, epochs, that repetition is running. And then save and reload your trained model. That is the complete mechanism. This, if you understand this, then maximum part is covered, right? So now if you see here, this is the train model running a model. First of all, lots of data. Here you will see tensor, then tensor is forwarded to the tensor out again. That means this is a training training process of the model, right? Now here you will see tensor, ground truth, and then you will see the loss function here. From here the loss function is coming, and from here the loss is calculated, and with the help of this, the torch model, this feedback is given to the torch model. Actually it's a little complex, so better understand this, right? Now this is what theoretically I have explained you. Now see here, today we are taking one new example, a real life example. What if I tell you, let's suppose if I give you a video, right, and if I give you some information that 5,000 subscribers are there and 50,000 watching hours are there already. These are related information of that video. So how will you recognize that that video is of a good quality, or what type of video is that? See, normally in our daily life, suppose if I see any video which is having 5 million subscribers, and then I will see that okay, more than 1 lakh watching hours are spent on that. So on the basis of this, we can determine that okay, this video might be good, right? Suppose I am a Python developer. Let's take another example. I am a Python developer, and I search for some API which is used in Python, right? Now I will check, suppose in the list of all the videos coming in the YouTube. Now what I will do, I will check, just a second. Now what I will do, I will check the list of video. I will not watch each and every video. I will check the how many million subscribers are there. Now see how YouTube works, how YouTube come to know that this video should be presented in front of you. The YouTube backend engine works on this data only: number of count, view count, like count, comment count. So basis on this, whenever you see, if you type any Python API, so it will show you that particular video on the top of the page which is having maximum subscribers. Or many times it happens that the video which is having maximum watching hours, right, maximum watching hours count, in that case also that video will be considered as a good content. So this is the daily life, real life example, that okay, we come to know, okay, based on this, because we are human and our brain understand that okay, these are the millions of views. But how the machine will consider any video to be a good content, that's the question, right? That's the question. Suppose if there is a scenario that in which you have to find out the best quality videos which are moving in the YouTube. Now YouTube, that means more than thousands and lakhs and crores of videos are currently there on the YouTube. Now out of which, what type of content, what type of videos that you have to select, and on basis of on which criteria. Suppose if I type bicycle on YouTube search bar, so that YouTube will first count that how many view count. First of all, it will check my location. I am from India. Then it will check how many view counts, how many subscribers are from India to which video, right? To which video is having maximum number of subscribers from India. After that it will check how many total views, then it will check how many total video of that particular company. After that, how many duration seconds. Look at this, this is the watching hours, duration seconds, right? Then description length, then the label, then the tag count. So based on that it will put, and this is done within the 2 or 3 seconds. Based on that it will put that particular video in front of me. So that is the same thing that we are going to understand in this session, right? Okay, now I think you might have understood exactly what we are going to do today, right? So that is the complete scenario that we are going to discuss. So for this, first of all, what we will do, here we have taken the data in the format of Excel. Right now here is YouTube quality video, that is the CSV, right? CSV format we have taken from the YouTube, that please give us your data, right? So they have given us their data with some limited data, right? Just 1 minute. Okay. So they have given us the data with some limited information. What is the view count, like count, and all these things, right? Now based on this we are going to train our model. And after that we will give one fresh data to that model, and what that model will say, right? In this way we will work in this session, right? So first of all, now just watch what I am going to explain you. First of all, let me open a new IPython file, that is interactive Python notebook, right? Interactive Python notebook. Let me start with a new notebook and I will show you practically one by one. YouTube videos, that's it, right? That's it. Okay, now see here, I have already written here the script. First of all, what we will do, we will first of all see, look at this. First of all, torch is a library, very important, neural network torch library, and then torch.optim as optim, numpy library for numerical massaging, and then numerical analytics, and then matplotlib as PLT for plotting the data, train test split, and then standard scaler and pandas, right? Decomposition I will explain you later. First of all, I will hit the enter button. Now wait for 2 seconds, all the libraries are pulled here. After that I will read that particular CSV, because we have to create one data frame. Directly CSV, we can't work on CSV directly. We have to pull the data from the CSV and save it into any data frame. Let me show you that also. Okay, now it is pulled. Now our next task is to read that data. So I am just entering the button, and now see, I have taken out all the 159 rows, right? So this data that we are having, and we are going to train our model on this data, correct? Now what's next? Now see here, now what I am doing here, now see values here. If you go to values, where is the values? no, values y equal to data. Okay, label access 1 drop label. Okay, this is the label that based on this yes or no, right? So that's the label that we have to delete, that is from x variable. As we already know, x variable is the set of independent values and y variable is the set of dependent values that we are going to extract, we are going to predict, correct? Now if I see, look at this x and y, if I type here y, then look at this. So label means the comment, exactly label means exactly the output that this YouTube video is of best quality or not. Now see here, print x shape and y shape. Now x shape and y shape is here. I think it is same, 160 is the row and 14 is the column. Similarly 160 is the row and 1 is the column. Okay, now what we are going to do, x train. Now again the train test split function, train test split variable, right? Look at this. Now see what we have done, x train x test, y train y test equal to train test split. Look at this, train test split, right? So train test split bracket comma x comma y comma test size, that is 3, that means 30% is taken for testing purpose and remaining all 70% for training purpose. And random state 42 means the data should not shuffle. Okay, I have explained you exactly why we have written this random state. I recommend you to watch my previous videos. Okay, now what happened here, 1 1 2 14 48 14, right? Everything is now clear. Now standardize features. Now see here, if I go here, now what is this, scalar equal to standard scalar, x train equal to fit to transform. Now we are fitting this data x train x test into the scalar, right? Then convert to PyTorch tensor. Now here the tensor comes into role. First of all fit the data, then convert into the tensor. Tensor means, you know, it's a matrix. Your face, the face recognition machine will convert your face into the matrix and then it will match that matrix, which is already your database stores your image, right? If it is 90%, because every time the face 100% identically match, that is not possible. Okay, now train model, here we come. Okay, just a second. Now training the model is done. Now let me show you this epoch, right? Epochs, that is the repetition. Training the model, for example, I have the very best example that I am giving you. Okay, first of all, see okay, how training the model works. Let me give you one real life example. I am riding a bike and on a cemented road, I fell down just because of a small amount of water was there, and the bike just fell down just because of that. So this is the first experience. Next time I will check, but next time some other due to some other technical fault, again that if the person fell down, so gradually the person gets trained after the experience, right? So same thing is here only. Epochs means 100 epochs, that's 100 repetition. What it will do, it will optimize zero gradient and then model, extend tensor, squeeze, and then criteria is given, then backward and loss dot backward. This is a standard formula. This runs 100 times, and after that optimizer 0 is not defined. Okay, optimizer 0. I think it is just give me a second. What's okay, one thing is remaining here, right? Defining, just a second. I think we missed one thing. We missed one thing here. Optimizer. we have to define first the optimizer, right? So just remove this. Here optimizer, the optimizer is defined here, optim.atom, and then parameter. First of all, this function, right, MLP. Then after this, this is the function that is sigmoid is used, that converts negative zero value into the negative points, right? After that, here input dimension x train shape, and now we are ready to go with our next this training the model, right? So training the model, we are going to look at this. Now the epoch is running, that means the repetition is running. Now our model is now trained, right? Our model is trained. Now evaluate model in trained data. Now see here, evaluate model in trained data. Now here, now see accuracy is 99%, right? So accuracy is 99%. And now what I will show you, just a second. Apply PCA for visualization, and here if you see this function, if I x underscore train underscore, if I hit the enter button, okay, it is showing the array. No, we will ignore this, that is something internal. So decision boundary plot. Now see, we are now just plotting the data. Now watch carefully what I am going to do. Now it is plotting that. Look at this, decision boundary of MLP PC reduced. Now see here, plot decision boundary. Now it is, we are just plotting the data, and you will see here the blue dots are the original data and red dots are the predicted. Okay, after this what we are going to do, there is one more method here I am showing you. Step predict on new data. Now what we are going to do, prediction on new data. Now see, now this data is given. For example, this 8154940, 8154940 means what? Let me 84, this is the view count, then like count, the next is like count. Look at this, this is the like count. And similarly I have given 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 total. Now this 2370 means what? 2370 means, look at this description length. So in this way we can put all the data here. This is a test data. Now test data, how it works, let me show you this. Now see here, predicted class, that is high, quality is high, and new data points, this is the new data points whatever we have sent. This predicted class, new data points is this new data, this is what the new data. And based on this, if the item class item is equal to 1. Now how, let's have a quick recap. See, this we have not done anything special, we have just trained the data, trained the model on 80% available data, and based on that we tested the data into the new data. That is what the mechanism works here. And in our all models, same mechanism is working. In PyTorch also same thing. First of all, what we will see, we will take the data into the data frame. After that we will separate the data. One variable is for independent data, another variable is for dependent data, right? After that you will see here, this is the shape that we have already for our purpose. Now train test split, we are splitting the data into two variables, x train x test, y train y test. After that we will see here standardized feature not convert into PyTorch tensor. Then we will convert them into the matrix. After that, that matrix, then we will create a function here, optimizer function, and then run that. Model is now being trained on that data model, optimizer model, and then we will evaluate how much is the accuracy. Then after checking the accuracy, we will just plot this data, and now our main task is to predict the new data. So we are going to predict this into the new data, how it works. Let me give you one more example. If you see any child, 2-year-old child, right, what he will do, he will just observe you speaking. We don't teach the language with the help of any book. That child, 2-year-old child, observe the face and the hand movements of her mother, and then gradually the child started speaking that particular language, right, without any book. So that is called training and testing. Daily the child watches and observe the faces and observe the words that we are spelling in front of the child, and then the child catches those words and then try to speak out those words. So that is called training and testing. But here what we have done, we are doing the same thing into the machine style, right? So there are different algorithms written here. So today we have seen how to extract or how to recognize that this video is of the best quality. So what is the criteria for best quality? We have already given that into the format of data frame or the Excel sheet. So take the historical data, then separate the data, then convert it into tensor, then create a function, optimizer function, then train that data, and after that put the original fresh data into that model, as just we have done this, and then run that model. So that in this way it will show you that how the data, how the machine works, right? So my suggestion is to you that just watch this video again and again, as I have been constantly telling you that if anything is not clear in first attempt, just keep on watching the videos, and my previous videos also, they are very useful. So watch those videos also, and then try to think out of the box, try to think, relate these things with your daily life examples, right? And then you will come to know exactly what is happening, because in first attempt if you try to understand the whole mechanism, that's a little complex, right? So guys, watch this video again, and then let me know how much did you understand. And after that, if anything is not clear to you, you can put your comment into the comment box. I will resolve them definitely. Okay, and those who are new, those who are the first time viewers, please like and subscribe my channel, and let's meet with some new techniques in our another bootcamp session, right? Till then you watch this and practice this. Okay, thank you guys, thanks for attending the bootcamp session.